Hi. So now that we have understood how to model systems, the use cases, the structural modeling, and so on, let's understand how to specify testing and how to test in general. So you need to learn how to design test cases that are most likely to uncover errors, an activity that should begin during the discovery phase itself before the development phase. Okay, so by specifying these tests upfront, you add measurable quality requirements and the clear-cut acceptance criteria for the software. So the testing process includes technical tests of the software's components and architecture, as well as tests to see if it works as advertised, and tests that see whether the software does these things well enough. So I'll just repeat this. The testing process includes technical tests of the software's components and architecture, which is called white box testing or white box tests. Then there are requirements based tests, which are basically tests to see if it works as advertised. And finally, tests that see whether the software does these things well enough, which is system tests, right? So white box, requirements based, and system. And who does these tests and how does the PM fit in? Why does the product manager bother? Well, the PM responsibility is to support testing. Okay, support testing. What this means exactly depends on the organization. Some organizations have a quality assurance team responsible for testing. The PM is often a member of this team. In fact, many organizations have people with a PM title who do nothing but testing. If you are a PM involved in testing, most of your testing time will be absorbed by requirements based testing. To jog your memory once again, requirements based testing is testing to see if it works, if the software works as advertised. That is functional tests. If your organization does not have specifically trained usability testers, you may also be asked to specify and or run usability tests. You will need to know how to design effective tests and how to write them up. In general, the rest of the tests, white box and most system tests, are too techy for the product manager. You still need to know enough about them to know what to ask for and to be able to understand the significance of the results, however. So like most things in product management, you need to understand, you need to know what testing is and how it works and how you can ask for it. You don't have to do the techie tests, which is the white box and the system test. Those are pretty technically advanced and you need to understand white box testing yourself. But in general, your main role is to support testing and make sure that you are shipping a well tested um, piece of software. So what is testing? Well, testing is any activity aimed at proving that the software system does not do what it is supposed to. Okay. The negative phrasing is intentional. If you just hear me out once again. Testing is any activity aimed at proving that the software system does not do what it is supposed to. So a test has a negative phrasing. Okay. Each time a test uncovers a bug, it has proven itself. It means the bug won't be released to the end user. The term quality assurance is sometimes used because it suggests that more than the physical testing of the software may be required. For example, verifying a draft of a system use case description with stakeholders is a testing activity, is a quality assurance activity, right? What exactly is a bug? We will take the very broad view for this. Okay. A bug is any variance between what the system is supposed to do and what it actually does. Some of these bugs are going to be introduced by the programmers, not intentionally, unintentionally, but others are introduced earlier on by business analysts through inaccurate, ambiguous, or missing requirements. Now, these are business analysts, these are product managers, or some business stakeholder who assumed something and he gave you certain requirements. It's your job to eliminate as many of these bugs as possible. So, what are the general guidelines for black box testing? Well, Ivar Jacobson is the founder of object oriented, the concept itself. He advises that you derive test cases from system use cases as follows. So test scenarios that cover the basic flow of each use case, which I hope you remember, basic flow is the happy flow. Test scenarios that cover the alternate and exception flows of each use case. Tests of line item requirements in the PRD, where the requirements are traced to use cases. And then tests of features in the user documentation, where the documentation is traced to use cases. Right? You will need more than these suggestions to plan appropriate testing. Fortunately, much groundwork regarding testing has been done prior to object oriented itself. So this pre-object oriented approach is called structured testing. We will look at how structured analysis can be integrated with object oriented techniques and applied to an object oriented project. But let me just still give you a brief understanding of what is structured testing and what is. So in 1976, Glenford Myers pioneered the field of testing with his book, The Art of Software Testing. He laid out a discipline he termed structured testing. His work remains the basis for testing to this day. So structured process testing is the process of using standardized techniques to locate flaws. Flaws detected by the structured testing include those introduced during business analysis, design, and programming. So when is testing performed? Well, different activities occur at various phases of project development. The structured walkthroughs are performed throughout the project. During the discovery phase, the test cases are designed. On an iterative project, architectural proofs of concept are implemented and tested as well during the phase. During the construction phase or the development phase, unit testing, which is tests of the individual software components or individual software units, that's where the unit testing comes in, is carried out. As system use case scenarios are implemented during the construction phase or development phase, requirements based tests are performed to verify compliance with the requirements. The requirements based is also called black box testing, which we just covered. And this is the requirements based testing is the one which, as a product manager, you must be decently comfortable with. And finally, before acceptance of the product, the developers or technical testers perform system tests. And finally, during the closeout phase, when you are completely done with the product and you are about to launch it, the user performs and supervises user acceptance testing, which is called UAT. Now, UAT is sometimes possible, sometimes not possible with the actual users, so you have to fake it. Like, for example, in big companies like Google, Facebook, etc., they will typically have they will typically have their products open up for their own employees, which gives them the early suggestions and early uh, uh, identification of bugs. And then once those bugs and those requirements are fixed, then the product is released to the public. Okay. So what are the principles of structured testing? And it is adapted for object oriented, right? So you begin by establishing some principles. Okay. Uh, you I mean So we will basically talk about principles to begin with, and instead of directly to techniques. This is because a sound understanding of the basic principles will avoid any kind of institutional problems that lead to buggy systems. So there are structured walkthroughs, right? Most people think of testing as a process involving the execution of a program by the computer. There is only one type of testing, and this is called computer-based testing. Testing, however, also includes non-computer based tests. How can you test a system without actually executing it? You walk through some aspects of the system manually with a group of participants. The formal method of doing this is the structured walkthrough. And why are these important? Because errors are often thought to be exclusively due to bad programming. In fact, they can be introduced at any stage of a project. The beauty of walkthroughs is that, unlike computer based testing, they can be performed before the software is written. Early testing means early detection of errors. The sooner errors are found, the easier they are to fix. Also, unlike computer based tests, walkthroughs tend to find the cause of a problem, not just its symptom. For example, a computer based test may find symptoms such as scattered situations where credit is advanced to non worthy applicants. A walkthrough may uncover the cause, an incorrectly documented decision table for evaluating credit applications. Right? So, what are testing techniques in a structured testing approach? Um, well, I have listed down all the tasks that you want to do versus and the tools that are probably helpful in that scenario. So, for example, if you want to test the speed, you can do a performance test, which is a type of system test. You want to test the requirements for completeness accuracy, you should do a structured walkthrough. You want to test functional requirements for end-to-end business process, you can do a high-level integration test based on business use cases, and so on. Right. So these are some of these techniques are beyond the structured testing scope itself. So treat this table as a reference point. So what are requirements based testing? The purpose of requirements based testing is to find variances between the software and the requirements. The product requirements document acts as a reference point of these tests. The term black box test is also used for these type of tests since the tester does not need to know anything about the internals of the software, such as the code and the table structure to design and to run them. Right? This is in contrast to white box tests, which are technical tests that are based on a knowledge of the inner workings of the system. So, what are the limitations? Well, since no knowledge of the code is assumed with requirements based testing, the only way to know definitely the effect that a particular set of inputs will have on system is to test the system's response to it. Right? You don't know anything about the internal structure. So the only thing you can do is you can give multiple inputs to the system and see what how the system is responding to it. This means that for full coverage, you would have to test every possible set of input values and conditions. In practice, this is an unachievable standard. So instead, you use techniques that help you design black box tests that will uncover the greatest number of bugs in a given amount of time. So there is something called use case scenario testing. So use case and scenario testing is one approach to requirements based testing that tests the various scenarios of each use case. Use cases lend themselves well to testing because of the narrative style of the use case documentation. It is already very close to being a testing script. And the way the use cases are organized into end to end business use cases and user goal system use cases, it matches the way the tests are organized as well. I have often been asked if use cases, then are all you need to design the test? Well, the answer is no. To design tests, you need more detail, such as graphical user interface screens, the structural model, which proves validation rules for attributes, and the documentation on business rules, stored in a business rules engine or kept manually in a folder. The system use cases may refer to these artifacts, but the artifacts are not part of the use case documentation itself. So, how do you derive use case scenario tests? Well, recall that your processing requirements were grouped around system use cases, each with their own group of scenarios. The flows were chosen so that they would cover all important scenarios: basic flow, alternate flow, exception flows. Basic flows are the normal path through the use case, which is the happy flow. Alternate flows are rarely occurring flows and other variations from the norm. And exception flows are the unrecoverable errors and any other flows that result in the interaction ending without the user achieving the goal of the use case. So what you do is you use the flows of the system use case to derive scenarios. Then test each scenario. For example, one test scenario might walk through the basic flow. You might be able to design another test scenario that walks through the basic flow and all of the alternate flows. At a bare minimum, you will want to ensure that the basic flow and each of the alternate and exception flows are covered at least once in the test scenarios. But you may also be interested in designing key tests that use certain combinations of the alternate flows. For example, one alternate flow for a stock trading site may be non-standard lot size, and another may be order can only be partially filled. The software may be able to handle each of these alternates one at a time, but not when they occur together. To test the system's response to this situation, you will want to include a test scenario that walks through both alternate flows. If you need to ensure you have covered all possible combinations of a set alternate flows, use decision tables, which we have covered earlier. During test execution, you will be looking to see whether the sequence of events during the test matches that described in the use case. One way to do that is to use the steps of the system use case as a source for the following test template. Place steps that begin with the user in the action data column of the template, which I've shared earlier, and place steps that begin with the system in the expected result response column. Essentially, just action and the response, action and the response. That's it. So all that comes in the user part. The user does X and the system responds Y. So the user does X should be in the action column, and the system does Y should be in the expected results or response column. Right. So this is a good template to work with. You can go as nerdy as you want, or you can keep it very, very simple. But having a structure to your testing would definitely help you um, get a good night's sleep when your product is about to get launched. So what is a decision table for testing? We did cover decision table earlier for use cases. This similarly, the decision tables are also used for testing. Um, so when the input conditions affecting a system use cases are interrelated, it is not enough to test for each input condition separately, because you also need to figure out the combinations. So you must test all combinations of input conditions. An input condition is any condition that will have an impact on the system response. Examples from a web retail site include item on sale, customer discount, and fast delivery method selected. You will find some input conditions documented in the system use in the system use case as alternate flows. For example, the alternate flow non-standard lot size. You might also see them already documented as part of the requirements in a decision table appended to a step of the use case or to the use case as a whole. In this case, you can reuse the decision table for testing purpose. From a testing perspective, each column in the table identifies a test scenario. Keep in mind though that the column only identifies the test scenario. It does not fully specify it. To properly specify a test, you need to complete the test template for each test scenario you have identified from the columns. Also, as discussed in the upcoming section, boundary value analysis will be covering. You may need to create more than one test scenario per column. The use of decision tables in this context may be complex, but that does not mean that this approach to testing is white box. The input conditions and the expected system responses are still derived from the requirements, not from an examination of the code. And that is why this classifies this technique of decision tables as black box. So what the decision table does not say about testing, the decision table shows only the net result of each test. It does not show the required sequencing of steps. For this reason, you need to complete the test template for each test scenario, indicating the expected sequence of actions. Use the system use case description to work out the expected workflow for each case. Also, each column tells you something about the input data for a given test, but does not specify exactly which data to test for. For example, in the diagram given, let's say the in column 2 in the figure, it definitely talks about the conditions. For example, the PC members, which is peace committee members, let's say, uh, the number of peace committee members may be 3, 4, or 5. Which of this should you use? What about tests for invalid data? These issues are addressed by boundary value analysis. So what is boundary value analysis? It's a technique for targeting test data most likely to reveal bugs. The technique is based on the premise that the system is most error prone at points of change. Boundary value analysis can help you pinpoint test data for any requirements based or black box test. If you're working from a decision table, then boundary value analysis can help you decide which data to use for the tests indicated by each column of the table. The technique covers both positive and negative testing. A positive test is one that tests the system response to valid conditions, that is success scenarios, and a negative test is one that tests the system response to invalid conditions or the errors, right? There's a whole bunch of rules that you can follow for conducting a boundary value analysis. I'm just mentioning some of them. Rest are there in the speaker notes. I'll recommend that you please go through it. So, for example, some of the rules are: if the condition states that the number of input or output values must lie within a specific range, create two positive tests, one at either end of the range. Then create two negative tests, one just beyond the valid range at the low end and one just beyond the high end. For example, for the system use case update case that accepts 2 to 10 parties to a dispute, the positive test would have the user enter exactly 2 and exactly 10 parties. Negative test would try for 1 and 11 parties. Right? Similarly, if an input or output value must lie within a range of values and the whole range is treated the same way. So create two positive cases tests and then create two negative tests. Right? For example, if the ward number attribute of the peace committee class has a valid range of 1 to 100, create two positive tests 1 and 100. Also create two negative tests 0 and 101. There are some more rules which I'll suggest that please go through at your own time. Now let's talk about white box testing. White box testing is a testing methodology based on the knowledge of the internal workings of the IT system. So, who does white box testing? Well, developers do it. You must be relieved now. Developers perform these tests since knowledge of programming code is required. But as a product manager, you have a supporting role. You may be required to specify the level of white box testing that a software must pass through before it is accepted. And after the tests are run, you might be called on to inspect evidences that the white box tests have been carried out successfully. This proof sometimes comes in the form of a report produced by an automated testing product, confirming the level of white box testing to which the software has been exposed to. To support white box testing, you need a basic understanding of what such testing can and cannot achieve and of the meaning of the white box testing levels. So, what are the limitations? Well, to ensure that software is completely error-free, white box testing must have to include enough tests to thoroughly exercise the code. In practice, however, this is impossible. Why? Well, at first glance, it might seem sufficient to execute a set of tests that causes every statement to be executed at least once. Unfortunately, this does not supply sufficient coverage because some errors show up only when a program's execution follows a specific path through the code. To white box test a program fully, then you would need to try all possible paths of statement execution. Because the number of tests usually required for full coverage is so high, other approaches are used to winnow the set of tests to a manageable size. And by the way, even small programs can have an astronomical number of pathways. To give an idea, consider an operation containing 20 statements that are repeated up to 20 times. The body of the loop includes several nested if then else statements. It would take about 1014 tests to cover all of the possible sequences in which those statements could be executed. So, which brings us to the next point, which is white box coverage quality levels. The following coverage levels are used to specify the degree of thoroughness of white box testing, listed in order of increasing coverage. Okay, depending on the level of risk, you may specify one of the following coverages: statement coverage, which is every coding statement is executed at least once. This coverage level is considered to be too low to be acceptable. Decision coverage. So every decision in the code has taken all possible outcomes at least once during the test. Decision coverage is the minimum acceptable level of coverage. For example, if the source code contained the decision age over 20 and license is under suspension, This expression would have to evaluate to both true and false at least once during the test. Condition coverage. Every simple condition takes all possible outcomes at least once. For example, in the preceding example, the decision is actually a complex condition made of two simple conditions: age over 20 and license is under suspension. For this level of coverage, the test must include cases where the condition age over 20 takes true and false outcomes and the condition license is under suspension takes true and false outcomes, which results into multiple condition coverage. So every combination of outcomes for simple conditions making up a complex condition is tested. For example, in just the previous discussion, for the complex condition of age is over 20 and license is under suspension, you would test few of these options. You will test age is over 20 is true and license under suspension is also true. Then age is over 20 is true and license under suspension is false. And all of these combinations, right? You might be wondering if decision tables play any part here. There's a role of for decision tables, but not in the context you learn to use them earlier in the topic. The conditions and actions in the tables discussed earlier were based on the requirements. The coverage tests we are currently dealing with, however, involve condition expressions and actions written in the source code. Decision tables can be used in the programming context to derive multiple conditions coverage tests using source level conditions and actions. Uh, but use of decision tables in this way is beyond your role as a product manager because of the programming knowledge it requires. So you can relax. Another important aspect is sequencing of white box tests. So when software is written, it is developed in modules or units. In structured systems, the software unit is the process, known by various terms such as subroutine, function, or subprogram. In object-oriented, the basic software unit is the class, which contains code for attributes and operations. In both structured and object-oriented environments, a plan must be put together to sequence the testing of these units and their proper integration within the software. The process of planning and executing this piecemeal test is called unit testing. So unit testing and the product manager. So while the developers usually carry out unit testing, the PM needs to be able to consult with the developers about the planning and scheduling of these tests. Since most systems in large organizations involve a hybrid of structured software, typically for back-end legacy systems, and object-oriented, which is typically for web-enabled front-end systems, as a product manager, you will need a basic understanding of unit testing in both the environments. So there's something called Big Bang approach to unit testing. Well, there are a number of approaches for the sequencing of unit tests. In the Big Bang approach, each unit is first tested individually. Once this is complete, all units are integrated and tested in one Big Bang test. Okay. In a structured system, these units are subroutines or functions. In an object-oriented system, they are classes. In either environment, the developers often need to create dummy software to stand in for other units not being tested at the time. One of the disadvantages of the Big Bang approach is that since units are first tested in complete isolation from the rest of the program, a large amount of dummy software has to be written. Another disadvantage is that the final Big Bang test is the first opportunity to test whether the units have been integrated properly in the software or not. If an integration problem shows up at this time, it will be very hard to diagnose because you have initially tested everything separately and then you essentially integrated everything and you said, okay, let's test completely. It will be very difficult to diagnose and identify what exactly went wrong now, if at all there's a bug now. So for this reason, the Big Bang approach is not advised, but it is still used because it is very easy to manage. Then there's another approach of incrementally doing the unit testing. So that is the preferred approach. Uh, so what happens in incremental approach is each unit is added to the system one by one. With each incremental test, the internal workings of a unit and its integration with the rest of the system are tested. Since not much is being added with each test, diagnosis is easier. In a structured environment, there are two types of incremental testing to choose from: top down or bottom up. Top down testing, basically, you'll start from the units are tested starting from the mainline program, the high level module that coordinates the major functions, and advances towards the low level units that carry out basic functions. The advantages of this sequence is that it mirrors the order in which software units are usually developed. The disadvantage is that since high level subroutines are tested before the low level routines on which they depend, the tester must create stubs, that is, fake units that take the place of the real low level routines before testing. And the second is bottom up testing. The bottom up testing, the order is reversed. First, the low level routines are tested, followed by higher level routines. The advantage of this approach is that it doesn't require the overhead of creating stubs. It does, however, require the creation of other stand-in software called drivers, but these are usually easier to develop. The big disadvantage is that this sequence may not match the order in which the units are actually coded, right? So this top-down and bottom-up, these are suitable only for structured coding, the older, if at all you'll end up in a company where, like in large banks or somewhere, where a lot of legacy code is there, then you might need to understand top down or bottom up. But for most of the modern companies, they will be using object oriented testing, in which object oriented programming, in which case you do not need to know about top down or bottom up. So in an object oriented environment, how do you test? How do you do incremental testing? You do it. Uh, so let's understand first that the units in an object oriented environment are not organized top to bottom. Rather, objects are seen as being on the same level, collaborating with each other to carry out system use cases. Right? It makes no sense, therefore, to speak of a top-down or bottom-up approach. Instead, the system use cases direct the sequencing of tests. When software is developed iteratively, as is common in the case with object-oriented systems, a set of system use cases is developed and released internally or to the user. During each iteration, only the classes and operations required for the scheduled use cases are developed and tested. With each iteration, more classes and operations are developed and tested until the entire system has been covered. Finally, let's understand system tests, which are the most technical of the lot. So once the black box tests have been completed, another battery of tests is executed. These are called system tests. With the exception of usability testing, which is a type of system test, you will not typically perform these tests. Okay, as a product manager, you will not be performing these tests, but you may be involved in planning them and in verifying that the tests have been conducted. So you should be aware of the tests in this category. The term system tests refer to a grab bag of tests that go beyond functionality. The purpose of system tests is to test compliance with the non-functional requirements, also known as service level requirements or SLRs. The non-functional requirements specify the required level of service, for example, the maximum acceptable response time or the latency, right? So Myers, who wrote the pioneering book on testing, he defines system testing as follows: the purpose of system testing is showing that the product is inconsistent with its original objectives. It is as broad as you can imagine, right? um, well, the idea behind system testing is that even if the code has been adequately tested for coverage, which is white box testing, and has been shown to do everything expressed in the user requirements, it may still fail because it doesn't do these things well enough, right? So imagine a website which loads the content, but it loads in 5 minutes or 10 minutes of time. So that again is not good for the entire software, correct? So basically what is happening is the software is not meeting other objectives, such as those related to security, speed, and whatever else that is important. So Myers laid out a set of system tests designed to catch these kind of failures. These tests are still widely in use today, and I'm mentioning some of them. So first is regression testing. Regression testing validates whether features that were supposed to be unaffected by a new release still work as they should. The test helps avoid the one step forward, two step backwards problem. A programming modification designed to fix one problem inadvertently created new ones. How much regression testing should you do? Well, that depends on the level of risk. Often, organizations create a problem review board to set standards for regression testing and to evaluate on a case by case basis the degree of regression testing required. Then there is volume testing. Volume testing verifies whether the system can handle large volumes of data. Why is this necessary? Some systems break down only when volume is high, such as a system that uses disk space to store files temporarily during a sort. Sort is an algorithm to sort, basically to search. When the volume is high, the system crashes because there isn't enough room for these temporary files. Also, some systems may become unbearably slow when volume is high. Often this is due to the fact that the data tables become so large that searches and lookup tables take up an inordinate amount of time. Then there is another system test called stress testing. Stress testing subjects the system to heavy loads within a short period of time. What distinguishes this from volume testing is the time element. For example, an automated teller system is tested to see what happens when all machines are processing transactions at the same time. Or a network server is tested to see what happens when a large number of users all log on at the same time. Then comes usability testing. Well, usability testing looks for flaws in the human factors engineering of the system. In other words, it attempts to determine whether the system is user friendly or not. Well, isn't it enough that the system does what it's supposed to do? Well, not really, because users may reject it due to the frustration with the user interface itself. In the speaker notes, I've added a bunch of questions connected to usability testing, which I'll suggest that you should go through by yourself. Then another form of testing is security testing. Well, security testing attempts to find holes in the system's security procedures. For example, the test will attempt to hack through password protection or to introduce a virus in the system. Then there is performance testing, where essentially performance is tested. You will look for response time, you will look for CPU time, you will look for throughput, you will look for storage testing, and so on. Then there is something called configuration testing. Configuration testing checks for failures of the system to perform under all the combinations of hardware and software configurations allowed for in the objectives. For example, this test looks for problems occurring when a supported processor, operating system revision, printer driver, or printer model is used. Right? Then compatibility and conversion testing. So often the goal of an IT project or a typical product is to replace some part of an existing system. The objective of compatibility testing is to verify whether the replacement software produces the same result as the original modules, with allowance for new or revised features, and is compatible with the existing system. Conversion testing verifies whether the procedures used to convert the old data into new formats work properly. So this is particularly very useful when you're doing a migration or when you're doing a major upgrade to your existing product. Then there is reliability testing. Reliability testing checks for failure to meet specific reliability objectives. For example, the objective for one of my early programs, a food testing program, stated that an automated count of bacteria grown on a grid be correct to a given accuracy. So the reliability testing would verify whether this objective was met. Another metric that falls in this category is mean time to failure. How long does it take for failure to happen? And finally, there is something called recovery testing. Recovery testing uh, checks for failure of the recovery procedures to perform as stated in the objectives. For example, an online financial update program keeps a log of all activity. If the master files are corrupted, the objectives state that a recovery procedure will be able to restore files to their state just before the crash by processing the day's transaction log against a backup of the previous day's files. A recovery test would look for failures of this procedure to recover the files. Finally, I want to talk about UAT because this is one thing which you will be interfacing most frequently. So acceptance testing is a final testing of the system before the users sign off on it. So this signing off of the users is basically a notional sense in a scenario where there's a client and a company contract. The user would be the client who would be go through the UAT and will check everything works as they asked for. That is UAT. But what about the direct to consumer apps and products, right? So nobody sits and signs off on Uber's functionality or let's say Airbnb's functionality, right? So in those scenarios, the UAT is usually conducted in a closed group, if whenever needed, in a closed group or closed user network, um, and it is not done in the way that you might imagine. So this test, or that is UAT, is often performed by the users themselves. Although in some organizations, the PM performs the test while the user looks on. There are two alternative approaches to UAT: a formal one and an informal one. So in the formal approach, the developers and users sign a document beforehand that lays out the terms of the UAT. The document stipulates that if the users carry out the UAT under the terms described in the agreement and if the tests are successful, the users will accept the system. By having participants sign off on this document before the UAT, the PM sets the stage for a clean end to the project. Right? Proponents of the informal approach argue that the formal approach is inappropriate. So, in their view, users should have free reign to experiment with the system to make sure that it can let them do their jobs, which might involve unexpected variation of the usage. Right? So, these are the two different approaches. And as you can imagine, the informal one is the one which you end up using most often. In fact, most of the SaaS companies, the freemium model actually just allows you to do exactly that. That they have built a software which they're selling for a certain fee per month, and they give you a free usage time of month of 2 months, whatever the time is, and you get to play around with the product and define whether you would like to use this or not. Now they also have something called enterprise pricing. Typically, an enterprise pricing is when they would customize the product to your requirements, right? Which is where the informal or formal testing will actually start coming in. So they will the SaaS companies would ask the enterprise exactly what is needed, so the requirements would be shared, and then it will be kind of a formal approach, but not as rigid. This rigidness comes in typically, I believe, in the Infosys or in the larger TCS kind of setups, where the contracts are signed and then you have to go through the UAT, and then if everything goes as you suggested or as you said, then you have no option as a client to accept the product, right? You can go through the speaker notes as well, because there's much more that I've written here. So about beta testing, about parallel testing, about installation testing, please go through that. Now, once you have understood all the different methods or different approaches to testing, let's specify some implementation plan, right? So the PRD must include an implementation plan so that steps required when releasing the system can be planned for in advance. Okay, it is just not enough to just write the PRD. You should also talk about how exactly this test will be implemented, right? So, for example, you can cover training, who is to be trained, how will training be done, what resources are required. You should talk about conversion, that is identify existing data that will be need to converted. So if there is existing migration that you need to take care of, you need to plan the promotion of programs from the current version to the new one. You need to plan granting of privileges to the users. You need to schedule the jobs. You need to advise operations. You need to do a lot of things. Essentially, it's very logical, very commonsensical, but it's important to just call it out, right? And finally, what are the end user procedures? You might also need to inform a lot of other departments like marketing department and sales departments and PR and so on. So, and the last is development and onwards, right? So we have gone through the entire process of modeling, of testing. Well, in here I do not have much to add. All I want to talk about is So as the project moves into the development phase, the developers, the system analysts, system architect, everybody, they start the work of adapting your business model for technical use, right? They will start actually building the product. On a waterfall product project, this is the point at which your active participation will stop. On an iterative project, you continue gathering requirements during the construction phase, the development phase as well, completing the requirements needed for the selected use case scenarios before they're implemented in an iteration. So you will basically be toe to toe with the developers. You will be just a little ahead of them in gathering the requirements and preparing for the implementation. In either case, once design and coding are underway, you need to be available to answer the questions that inevitably arise during the development process, right? So to conclude, I mean, most likely you would be very, very overwhelmed with the sheer number of concepts you have to remember. So, not much to worry though, as you won't be implementing everything described here unless you're working on a very, very complex product in a very large organization. You don't have to be pedantic either and produce perfect UML diagrams, unless, of course, that's what you have been asked for. The idea is you need to be aware of these various tools, with the various techniques, the various approaches at your disposal to model various scenarios, right? Most of the time, you will not be using all of these things. You'll be using very, very few of these models and very, very few of these elements. But one of those boundary conditions, or one of those odd conditions, odd scenarios where you will be where you're tasked with a very different, very challenging problem, then you have some concepts or some curriculum to go back to, right? So as long as you are able to clearly articulate what you want to be built, you are good to go. Okay, just remember that. So that's it for now. Thank you.